This work, entitled Thermal Behavior Assessment of Two Types of Roofs of the Dominican Vernacular Housing, was prepared by Esteban Prieto Vicioso, researcher at the Universidad Nacional Pedro Enriquez Ureña, Virginia Flores Sasso, and Letzay Ruiz Valero, both from the Pontificia Universidad Católica Madre y Maestra. This presentation will cover the following topics: introduction, case studies, materials and methods, results and discussion, and conclusions. The use of thatch roof is as ancient as the construction of the first houses. Thatch roofing is a traditional roofing method that involves using dry vegetation. From the Industrial Revolution onwards, many thatched roofs were replaced by metal sheets, which was a new material that promised many advantages over the other. However, when using it, no changes were made in the design, and one material was simply replaced for another, which affected the thermal comfort inside the buildings. For this reason, the aim of this research is to evaluate the thermal behavior of two roof types of vernacular housing. One type is a Cana Palm leaf roof, and the other is a corrugated sheet zinc roof. 4 houses were assessed for this research, all located in the Bani Valley, in the south of Hispaniola Island. 2 of them have roofs of Cana palm leaves, B1 and B2, and 2 with roofs of corrugated zinc sheets, B3 and B4. All the bohíos were built in the second half of the 19th century, which can be verified by the data offered by the owners and by the presence of cast iron nails, used before the 20th century. The floors of the 4 houses are made of polished cement. The bohíos B1 and B2 with a Cana palm leaf roof are a type of vernacular housing commonly used in the Bani Valley, which consists of a simple volume with a rectangular floor plan, with a gabled roof and small eaves that protect the 4 facades. Its supporting structure is based on wooden forks, buried in the ground, joined at the top by the sill, on which rests the lock that supports the thick cover of cane palm leaves, Sabal Dominguensis. The walls of the house and the internal divisions are made of planks of royal palm, Roystonea Hispaniolana, placed horizontally, overlapping, and nailed to the horcones, or posts, which in this region are usually made of mahogany. Suetenia mahagoni, or Creole oak, Catalpa longissima. For the structure of the roof, uncarved sticks or poles from various local timber trees were used. Both bohíos have a door in the middle of their main facade with 4 windows, 2 on each side of the door. On the back facade facing the patio, they also have a door placed in the center with 4 windows, 2 on each side of the door. The spatial distribution of the interior consists of a central area divided by 2 low walls, called handrails or pasamanos, which define the living and dining areas. On both sides are the bedrooms, 1 on the right and 2 on the left side of the bohío. The kitchens and latrines are located outside the bohíos, where there is also usually an enramada, or covered terrace. The B3 and B4 huts, located in Sabana Buey, have a supporting structure, materials and construction methods like those of the B1 and B2 huts, but with the difference that the roofs made of Cana palm leaves were replaced years ago by corrugated zinc sheets, which are nailed to a structure made of already industrialized wooden rafters and roof battens, usually made of pine. The roofs are gabled with short eaves, with the main facade being somewhat more pronounced. In these houses, the zinc roofs have a smaller incline than the palm cane, due to the fact that the palm cane requires a greater angle to expel the water and move it away from the facades. Both cases have an annex at the back to integrate the kitchens into the house and to add another bedroom. The interior walls, as in B1 and B2, remain at the height of the sills, allowing air to flow over them. B3 also has fans over the doors, which contributes to the good ventilation of the interior of the hut. The Dominican Republic is in the Caribbean, in the tropical zone of the Northern Hemisphere. It is classified as a subtropical climate that varies according to the location, due to the topography and the trade winds of the northeast. In general, the geography of the country has created two types of climates: a tropical rainforest climate and a tropical savanna climate, according to the Köppen-Geiger climate classification. The climatic variations are marked, ranging from arid to very humid. Peravia Province is in the southern region of the country, approximately 60 kilometers west of the city of Santo Domingo, which belongs to the coastal plains of the Caribbean. On average, the warmest month is August, with a maximum of 38.2 degrees centigrade. The lowest month is January, with a minimum of 20.5 degrees centigrade. The average relative humidity is 65.7%, with an average precipitation of 77.64 millimeters, and the average wind speed is 4.375 meters per second. Average daily hours of light is 9 hours. These climatic conditions, hot and humid, and the properties of the material affect the thermal comfort of the buildings, causing a significant increase in the indoor temperature of the building. Non-destructive techniques were used to evaluate the houses. The equipment used included a hygrometer, TPI 1010 outdoor-indoor air quality meter, infrared thermography, and surface temperature. Also, official weather stations in the vicinity were consulted, as well as the National Meteorological Office. The measurements were taken during the warmest period, from June 8th to September 28th, 2019. Some additional measurements were taken on June 8th and July 9th, 2019, between 9:30 and 15:40 on a sunny day. The temperature and humidity were measured with an X-Tech RHT-20 data logger hygrometer. 4 hygrometers were installed in the houses, 2 inside and 2 outside. The sampling rate was every 30 minutes from 0:21 hours to 23:51 hours. The additional measurements taken on June 8th and July 9th were done with a TPI 1010 outdoor-indoor air quality meter that measures carbon dioxide, CO2, carbon monoxide, CO, air temperature, and relative humidity. For the surface temperature, we used a digital laser thermometer, Master Grip, that has a temperature range between negative 28 degrees centigrade to 482 degrees centigrade, and with a Class 2 laser pointer. Several measurements were carried out in each roof, one inside and one outside, to check the thermal jump effect. The study of infrared thermography is based on passive thermography, which measures the temperature differences of the roof that are generated under normal conditions. Thermography images were used to analyze upper and lower surface thermal characteristics for the 2 roofing materials. The measurements were taken with an infrared camera, FLIR Systems Model T420, FOL 18mm lens, and 240 by 320 pixels infrared resolution. The camera has a spectral range from 7.5 to 13 microns and has a field of view of 25 degrees by 19 degrees and a spatial resolution of 1.36 milliradians. It has an adjustable thermal range from negative 20 degrees centigrade to 650 degrees centigrade, and for this project was set at negative 20 degrees centigrade to 120 degrees centigrade. The camera used for this survey meets the requirements of UNE 13187 of infrared thermography. The emissivity values for Cana Palm leaf roofs, are 0.75, and for corrugated zinc sheet are 0.20, as shown in Table 1. For thermal images, an iron color palette mode was used, using reference colors, blue for the coldest temperature range, and yellow for the warmest temperature range. This way, the coldest point can be identified on each image. The recorded outdoor temperatures were a maximum of 38.2 degrees centigrade at 12:21 in Sabana, Buey, a minimum of 24.2 degrees centigrade at 6:51 in Villa Sombrero, with an average of 30.6 degrees centigrade. The recorded outdoor relative humidity was a maximum of 88.7% at 1:51, a minimum of 37.7% at 12:51, with an average of 65%. The recorded indoor temperatures were a maximum of 36.8 degrees centigrade at 1:21, minimum of 22.5 degrees centigrade at 6:51, with an average of 28.8 degrees centigrade. The recorded indoor relative humidity was a maximum of 83.5% at 22:51, a minimum of 41% at 13:21, and an average of 62.6%, as shown in Table 2. Air quality measurements indicate that B1 has a higher concentration of CO2 indoors than other samples. It is possible that this is due to the fact that the house is closed all day, which prevents it from renewing air. But in general, all the houses have a great amount of CO2 in comparison with the outside, as shown in Table 3. The average outside surface temperature of the Cana Palm leaf roof was B1, 38.5 degrees centigrade, B2, 46.5 degrees centigrade, and inside B1, 30.1 degrees centigrade, and B2, 32.3 degrees centigrade. And the average temperature outside of the corrugated zinc sheet was B3, 47.5 degrees centigrade, B4, 49.2 degrees centigrade, and inside B3, 50.5 degrees centigrade, B4, 48.5 degrees centigrade. We can observe the different surface temperatures between the Cana Palm leaf roof and the corrugated zinc sheet. Through thermal images, we can observe some variations in temperature of both upper and lower surfaces. In the case of the Cana Palm roof in B1, the maximum outside temperature is 44.3 degrees centigrade, and inside temperature is 31.8 degrees centigrade, with a difference of 12.5 degrees centigrade, while the minimum outside temperature is 34.8 degrees centigrade, and the inside temperature is 27.5 degrees centigrade, with a difference of 7.3 degrees centigrade. B2 presents the maximum outside temperature of 54.9 degrees centigrade and inside temperature of 33.4 degrees centigrade, with a difference of 21.5 degrees centigrade, while the minimum outside temperature is 36.2 degrees centigrade and the inside temperature is 30.2 degrees centigrade, with a difference of 6 degrees centigrade. On the other hand, in the case of the corrugated zinc sheet in B3, the maximum outside temperature is 51.6 degrees centigrade and the minimum inside temperature is 50.5 degrees centigrade, with a difference of 1.1 degrees centigrade, while the minimum outside temperature is 42.5 degrees centigrade and the inside temperature is 35.4 degrees centigrade, with a difference of 7.1 degrees centigrade. B4 presents the maximum outside temperature of 55.5 degrees centigrade and inside temperature of 54.2 degrees centigrade, with a difference of 1.3 degrees centigrade, while the minimum outside temperature is 41.4 degrees centigrade and the inside temperature is 36.9 degrees centigrade, with a difference of 4.5 degrees centigrade. In conclusion, the Cana palm leaf showed better thermal efficiency than corrugated zinc sheets, providing lower values of radiant heat load and surface temperatures, as well as lower temperatures inside the houses. In the case of Cana palm roof, the maximum temperature difference between outside and inside is 12.5 degrees centigrade and 21.5 degrees centigrade, while in the corrugated zinc sheet, this difference is 1.1 degrees centigrade and 1.3 degrees centigrade, obtaining in the interior practically the same temperature as the exterior. We can observe that the indoor ambient temperature at B1 and B2 is like the maximum surface temperature of the roof material. In the case of B3 and B4, there is a great difference between these temperatures due to the construction system that creates some openings between the sills and the roof, allowing inside ventilation. Using infrared thermography, it was possible to produce heat maps to quantify surface temperatures and thus observe and evaluate the thermal efficiency of both materials. This process helped us to understand the processes of heat transfer between surfaces, confirming in this research that the thatch roof is much cooler and transmits less heat to the interior than the metal roof. Thank you. Muchas gracias.